Okay, let's pick up 3.5 where we left off. Okay, let's look at number 2. 3 over x minus 4 obviously doesn't reduce because nothing canceled. Again, there's no holes, no shared factors. Now, let's look at what happens to our vertical asymptote. X minus 4 equals 0, which means x equals 4. Horizontal or slant asymptote. Here, the denominator has a larger degree than the numerator because there's only one with x. And again, as x gets really big, it's going to overpower that 3. When the denominator is greater than the numerator, you automatically have a horizontal asymptote at y equals 0, which means no slant asymptote. So how will we know we have a slant asymptote? Let's see. X squared plus 3x plus 4 over x minus 5. This is the first thing that could require us to factor. There are two numbers that multiply to 4 that add to 3. No, so there's nothing to factor here. If there's no factors, still no canceling, which means no holes. Okay, so vertical asymptote, we take our remaining denominator factors, x minus 5 equals 0, which means x equals 5. Horizontal or slant. Our numerator is greater than denominator by 1, which means we have a slant asymptote. To find what that slant asymptote is, I need a y equals mx plus b, which means I need to divide these two things to get my mx plus b. Let's use synthetic division. How many times does 5 go into, well, it's 1, 3, 4. 1 times 5 is 5. 5 plus 3 is 8. 8 times 5, 40. This is 44. The remainder 44. So this is really the line x plus 8 plus 44 over x minus 5. However, again, what happens is x gets really big, it overpowers the 44, and this thing will become 0. So the only parts we actually care about are the mx and the b. So it's this part, we don't care about the remainder, so you can actually stop the process there. Y equals x plus 8 is my slant asymptote. So it's going to be a y equals mx plus b. The b could be 0, but in this case the m should never be 0. That would imply 0 came down and we didn't have the power in the first place. So here we have a slant asymptote at y equals x plus 8, our vertical asymptote x equals 5. There are no holes. And since there's a slant asymptote, there's no horizontal asymptote. Now we can do another. This one's already factored for you. So let's see what happens when it's already factored for you. X plus 4 over times x minus 1 times x plus 2 over x plus 4 and x plus 1. So here we have x plus 4's that cancel. When something cancels, we have a hole at x equals negative 4. It's whatever makes that 0. We have this left. I'm going to multiply these out. This is x squared minus x plus 2x, so plus x minus 2 over x plus 1. We only factor to check factors, but if the potential of a slant asymptote is there, that's more important. The denominator you would like to leave factored for vertical asymptotes, but we already know what they are. To figure out the y value that goes with this, we know negative 4 is the x, we have to plug negative 4 in for the rest. So negative 4 squared would be 16 plus negative 4 minus 2 over negative 4 plus 1. So that's 16 minus 4 minus 2 over negative 3. So that's 10 over negative 3, or negative 10 thirds. So the y value is whatever happens when you plug in your hole to the remaining portions. Okay, so vertical asymptotes now come into play. X plus 1 equals 0, which means x is negative 1. Lastly, horizontal asymptote or slant asymptote. We have the numerator as the greater power by 1, because x squared over x, which means we have a slant asymptote. We have to divide them. So negative 1 on the outside, 1, 1, negative 2 on the inside. 1 comes down, 1 times negative 1 is negative 1. When I add here, I get 0. I don't care about the remainder, so I can stop the process. This is the line y equals x plus 0, which means it's just y equals x. So we have a slant asymptote of y equals x, a vertical asymptote at x equals -1, a hole at the point -4, -10/3. That means there's no horizontal asymptote because of the slant. Okay, so the idea is, how does this work from a graphing perspective? How do all these features help us? So we'll go step by step. We fully factor. Let's fully factor everything we can. X squared plus 4x minus 5. That is x plus 5 and x minus 1. You ask yourself, does any factor cancel? There's no cancels, which means no holes. Okay, vertical asymptotes, we've got 2 in this case, which is fine. You can have as many as you want. Well, as many as the problem dictates. 1 at x equals -5, 1 at x equals 1. These are vertical dotted lines that aren't part of your graph. So go over to -5, make a vertical dotted line here through -5, and 1 at 1, vertical dotted line. Once we've done that, we do horizontal or slant asymptote. The denominator is the larger power of x, so that means it's automatically y equals 0, which will be hard to see. But again, it's a dotted line because it's not part of your graph. It is a guideline for your graph. This is y equals 0. Once you have those, we need to find actual points on the graph, so we'll do the intercepts. So we start with the x-intercepts, which involves setting the numerator equal to 0. So x plus 1 equals 0, which means x is -1. Now the x-intercept is always a point, -1, comma 0. You can cross an asymptote in the middle. Remember, it's the end behavior. You can only cross horizontal asymptotes. You can't cross them on the outside, so keep that in mind, and you can never cross vertical asymptotes. The y-intercept is what happens when you plug in 0. So that would be the ratio of our coefficients here. 0 and 1 over -5, so -1/5. So we'll plot that here. The question is, how do I find what's graphing? So again, I can check positives and negatives using a test chart. All of my asymptotes and intercepts will go on there in order. So -5, -1, and 1. We test easy points in the middle of these. And we only need to see, really, I guess we can plot them. We know what happens when we plugged in 0. We got a negative number. It was 0, -1/5. It's already plotted there. That means all the numbers between -1 and 1 will be negative. If we plug in -3, that's -3 plus 1 over -3 plus 5 times -3 minus 1. It's -2 over 2 times -4. That would reduce to 1/4. So when we plug in 2, we get 1/4. Wait, we plugged in -3, we got 1/4. Sorry, -3, 1/4. So -3 is a positive number at 1/4. Let's plug in -6. So -6 plus 1 over -6 plus 5 and -6 minus 1. It's -5 over -1 times -7, which is 5/7. So we have -6 5/7, which is a positive number. And we will continue this in the next video.